Hello friends, welcome to this tutorial on how to work with Upper/DB. If you have been working with data access in Go, you will realize that it requires a lot of repetition. So let me show you an example. When you fetch data from the database, look at your columns, you have to do this manual mapping that we are passing pointers to the fields by ourselves, right? So imagine if you have like 50 columns that you are retrieving from the database, you have to do this 50 times. And when you change the order of how these things are retrieved, you also need to change the order which you are mapping them. For me, this is a huge productivity problem, and I was looking for a way to solve this problem by just looking for a way to get this automatic mapping happen for me. So I found Upper/DB while I was working on this tutorial. So this is something I'm currently working on, and I'll be publishing it very soon. It's a fantastic project, all written in Go, and I'm using the Upper library for this tutorial. So if you want to enjoy this one, please subscribe to my channel so you get a notification. I publish videos mostly on Go, and very soon some will be on PHP. All right, so let's switch back to Upper and see what it has. You can go to the Getting Started to see database support, including NoSQL database like MongoDB, and you can take the tour to see how it works. I'll switch to an empty directory here. This one is empty, and I'll go to Go mode, init. I'll just write Upper example YouTube, something like this, right? So it will create a go.mod for us. And I can go ahead, do touch main.go. That gives us the main file, and we can create a main function inside with the hello world. I like to start with hello world to make sure things are working very well, that my compilers and everything is good. So I'll just do go run. I'll put the dots to run this main package that we have. Fantastic. It looks good. Next step is to install the Upper package. So I can say go get. So I have autocomplete going on here. Hub, github.com/. Let's look at what the Upper gives us. So let's look at the example. So it's Upper/DB, and this is the Postgres adapter. So you see, we bring in the Postgres adapter that would bring in the dependencies. So we just go straight to that one. We're going to need the base, which is this UpperDB/v4, but we also need the Postgres adapter. You see, we have the v4, which is the main dependency. All right, let's look at our Go mod file to see what it has pulled in. It pulled some Postgres library, especially this one. I'm very familiar with it. And this is the Upper. Fantastic. So there are some steps you need to take. First, we need the settings. Two, we need the connection. And three, we can interact with database. Like really straightforward. So I have 3 steps, so we can go ahead and do the, I can, if I want, I just put outside here, so settings equal to, what do we need? So we have this Postgres adapter. We need the connection URL, and this is struct. We need the host. For me, it's localhost. We need the database. I have a database in my Postgres called ABBA. We have the user is going to use Postgres, and password will be Postgres. Very something that it's important when you are working in a production environment. Never leave your database credentials this way. You want to bring it in from your environmental variables, but I don't want to keep on setting those environmental variables. If I have them set, I could get it like os.getOnv. All right, so this is enough for this tutorial. So step one, this is step one, settings. Step two, connection. I like to do the connection inside here because I want to check for errors. So I would say DB, or in their documentation they use sys for session. So I can DB equal to Postgres ql.open, and then we pass the settings, right? Of course, just like everything in Go, this is error. You need to check for error. And if error is not named, we want to log fatal at this point. Here, we now have connection to the database. So step two, done. Step three is interacting with the database. So what I want to do is to list all the tables in my ABA database. So let's just say tables, says.collections. This one should give us all the tables. Let's say if it returns an error. Yes, it does. Returns an error as well. So that means we need to bring this code. You see that we continue copying this error check. So we can just do check error at this point. So just simplify our error checking and put this code. Then we just do check error. This place, check error. We simplify the error checking process by extracting the code into a function. Next step, we have this table. So I'm going to ignore the index and say tb equal to range tables. And then we just go ahead, printf the name of the table, which is tb.name. All right. At this point, we can run our program to see. Fantastic. We can see something, but sure, we need to put a new line to see it properly. So we see all the tables in our database. We have books, author, subject, articles, many more. So let's focus on this books table. For now, I actually don't remember the name of the fields in those tables. So I want to pause and check the list of the fields in those tables, and then I'll be back. All right, so these are the tables. So let me close this article. So for the authors table, we have ID, first name and last name. Books, we have ID, title, author, ID, and the subject. So let's focus on the authors table, which is just 3 fields, simpler. We bring it over here, and I will create a type called author struct ID. I'm going to make it an int. We have first name, which is a string, last name, which is a string, right? So how do we tell Upper what to do with these fields? You need to add some tags. You need to add DB tags. So you say DB, you know how tags work in Go. So this one is an ID. The field name in database is ID. And because this is an auto-generated field, we want to say omit empty. That way, Upper won't try to generate value for this. Then DB, the field name in database is first name, and this is last name. That's all we need to do. I won't be printing. I think I can just ignore this for now. And if you do this, just like this, right? Okay, so what do we need? First of all, let's create something in the database, in the authors table. I would say the table, author table, TB, is equal to says.collection. The name of the collection is authors. That gives you the table. Now we can use this to say, let's say the return ID from the table and error would be author table.insert. What can we insert? There are 2 ways to insert. One is to use a map. Another one is to use the struct. Let's do both. So I will do author, And ID, because we don't need to set ID, just set first name is upper and last name will be DB. That's it. What we check for error. If there are no errors, we want to check because this returns an ID actually. So if you do res, you see res.id. So I will just go ahead and do printf. I'll put a v. The ID is not an int, so it's some sort of interface that is being returned here. So you need to do some conversion, but let's keep it that way. Run it. We should see the ID value 16. Great. So let's fetch. So this is okay. What I want to do, let me do another one. Then we go ahead and do the fetching again. So step 2, instead of using the struct, let's use map of type string, and I want to do first name upper 1 or upper 2 this time, last name db2. Right, so this is another way of inserting data to the database. 17, fantastic. All right, I want to delete this one now, and this time I want to do, let's say res equal to, first of all, let's fetch the last value that we inserted, which is 17. So I will say var author is author, right? And I will do error is equal to author table, this one, dot find. There is a DB condition map that is predefined, and you can say ID. The ID is 17, and then we do 1 because we are just fetching a single record now, and then we pass reference to this variable that we have here. If there are no errors, at this point we should have author, which I'm going to print by tagging a plus here. Run it. You see, ID is 17, first name is upper 2, last name is db2. Fantastic. How about fetching a list, an array? So we have about maybe 17 records, I don't know, let's say authors, and a slice of author, right? Very similar idea. In short, we're going to copy everything here, bring it down here. I will do check error, but this time it has to be authors, and it needs to be all, and then we take out the condition because we don't need any condition at that point. So this, let's bring this one here, put a new line, and we print this one as well. But this time around, we print the authors. Run it. Look, we have everything. The slice, everything. So this is a very powerful way of doing things. I don't know about you, but for me, this is a huge productivity gain. You don't need to suffer yourself, trying to do the manual mapping every time. Very similar approach, just like you have insert. You can have update and delete. So if you have a record, for instance, if you have a record where is a find, instead of you calling 1 on it, you can call delete on it, right? Great. So this is it. It supports joins and all that. But also you can do SQL. So let me show you something about the SQL. Says it has a dot SQL, then you can say select what do you want to select, ID or whatever, and what else. You say select ID or on, you see all the queries here, where and everything. So you can do 1 to map select ID first name, from authors, where takes what. So you can look at it as where takes a condition. So that brings you to this db.condition. And you can say where ID, maybe you can say ID greater than, this time around 3 or something like that. What is the, sorry, I need to put a colon there. ID greater than 3. And because we are fetching, let's make this one 2. At this point, we can say all and pass it to these authors. We should get an error here and check for error immediately. What else? So what I want to do, instead of printing everything here, I want to print the count. So learn this one, then we print for the second one as well. This one as well. So to see the difference, because here we added some condition, this one nothing. So very flexible, trust me, very flexible, time saving and all that. So you see 16 and 13. Great, we're doing greater than 3, that means it's taking from 4 down. It works very, very well. So this is where I want to end this video, but I want to take you to the tour just to browse through it to show you some of the great things you can do. You see, it supports you can bring in any adapter, the connection. What else? We saw this one. The collection name, this is what we did, like table name and all that. We can do, this is the mapping of database. We've seen how this works. Also, you can do something called inline, where you embed like different structs. We've seen this, all right? This is the query builder that we just saw. You can order things, yes. There's pagination as well. So this is how to paginate your results. Really good. And supports different error logging and all that. So this is really, really good. Here, I'll stop the video. Like I said, let me show you quickly how I'm using it on this is where I'm connecting to it from this project. And it's worked really well. It's worked really well. If we go to my data access layer, this is users. You see, I have it here configured. But the way I'm using it is I have models. So let me show you. So users model depends on DB session. Then I started attaching methods to this. So m.db collection, get the table name, find the record, and then map it out and return it. So see different error handling approaches that I've taken. Find by email, just email condition and all that. So this is very powerful when I'm configuring the models. If you look at what I'm doing here, where is models? Look at when I'm returning the new models, like users model, for instance, I just pass in the dependency var parameter. So this is really, really good. Like I said, this is the tutorial that I'm currently working on, and I'll be publishing it soon. It's listed on port 4000. Let's take a look at it one more time. It's a great project. You can sign up quickly. Let's say mark@me.com. Password is password. An account created, you can now log in. So mark@me.com. Password is password. And great, I'm logged in now as Mark, and I can share news, right? Go submit a news. Let's go to where we can find news. CNN. Most people read CNN. I don't know, something I want to go towards politics or entertainment, something not very controversial. Oops, can we find a good news? Entertainment, basically. Tech, innovative. Sounds more like it. Okay, so I take like this is the title of the URL of the news. For the URL, it's like a bookmark, right? You just bring in the title and then submit it. So it's right here. Let's close this. So you bring in some comment, good news, some awesome news. I don't know if it's a good news or not. Just doesn't it. Your comment is not about it should be written wrong. Some news and comments, some random stuff. All right, just put a comment. There's now one comment, and when you go there, you see one comment. You cannot vote. So if you like this, what you're seeing, please subscribe to my channel. And when I publish this, you get notification. You can sort it by popularity, which is the number of votes. We can see more per page. If you don't want to see more per page, it support pagination and all that. All right, you see, so you can paginate the content. And then you can go back to page. Fantastic. See you guys. Bye.